Hi, this is Professor Stugard, and in this video we're going to discuss strings. So in this video we're going to talk about two things. We're first going to kind of talk about how the programming language R interprets and understands strings or character vectors, and then we're also going to talk about several important functions that come in the string R package that let us do different types of analysis tasks based on text and characters and strings. So first of all, a string is really a character vector, and we can use these two phrases, strings and character vectors, interchangeably, and in fact that might help you understand what a string is a little bit better if you think of it in terms of being a character vector. Because a character vector is really just any string of letters, numbers, and symbols. Now, in R, we can denote strings in two ways. Typically, we use the double quotes around strings, but we can also use single quotes as well. We typically do want to use the double quotes whenever possible, but if the string itself has double quotes on the inside, then we do want to use single quotes on the outside because, again, R doesn't really understand natural language. It's a computer, and it's only going to interpret the string as what's in between your first two sets of parentheses. So if you, or first two sets of quotation marks, sorry. And so if you have two quotation marks in a string, well, it's just going to start and stop, and it's not really paying attention to what's really going on. So it's just one thing to kind of be careful about when you're dealing with strings, particularly strings that would have quotes in them themselves. But once we do have it stored, when we think about it as a character vector, it does help us quite a bit because when we've talked about vectors, we can index vectors. There's a first element, there's a last element, there's all the elements in between with vectors, and we can absolutely manipulate our strings that same way with that same kind of understanding. Now, like I said, we can index strings, but it doesn't always work exactly like we would expect it to, and that's because we interpret things using our intuition as humans, and unfortunately, computers have no intuition. They're only going to do exactly what you tell them to do, not what you want them to do. So let's look at an example. So let's say in the variable words, I have stored the phrase, the character string, data science is cool, all together. Now, like I said, it stores this as a character vector, so we would think that we could be able to index it in a normal way. Well, if I try to index this, if I take the second, right? So I'm going to index what's in the second position. My intuition would say, oh, well, the second word is science. Except R is going to say, no, it doesn't exist. That's missing. Because for R, when it sees that sentence data science is cool, we interpret it as four words because we understand that the space separates individual words. To R, it does not see the space as separating words. To R, it sees that space as any other symbol. The space is no different from an A or a plus sign to the programming language R. There's no reason that it would interpret the spaces differently. So again, if I store that phrase, data science is cool, again, that's one long character vector. If I index the first element, it's the entire sentence. R says it's the entire thing. Everything in that quote is my first element because it's all together. Everything in the quotes is that first element. There's one and only one element in my variable words. Now that we have that in mind, luckily somebody wrote the string R package, and it's part of tidyverse, so we're going to have it loaded by default almost every time we do a project anyway. And it is so useful to allow us to manipulate and search and filter all of our different character vectors. And the nice part about the string R family of functions is that every function in the string R package starts with str underscore. So you can actually go in your console, assuming you've loaded tidyverse, type str underscore, and you'll see it'll start to autocomplete a whole family of functions. And you can go through and you can look and you can hover over them, and again you can search the help functions on the string R package and learn about all of them. We're going to cover just a few important ones, probably the most useful ones for our purposes in this class. The first of which is the string length function, which basically does exactly what it looks like it's going to do. It's going to tell you exactly how many characters there are in a string. So let's again say we have our variable words with data science is cool. If I want to find the length of this, I run my code and it's going to tell me that there are 20 characters. And again, you can count it up. DATA, that's 4. And then remember, the space counts as a character. R is counting that space. That space is no different from any other character. So it would be 5 and then science. And again, you can count it up yourself. I don't feel like counting to 20 right now. But pause the video and count to 20 and go along on your screen, right? It's counting the spaces as any other character in this particular string. And again, that's just something to keep in mind, that spaces are characters and R sees no difference between any of the characters, and that includes spaces. Next up, sometimes we want to subset a string. And this means we take a string and we're basically going to chop off some part of it. And we use this using the string sub function. So str_sub. We want to supply 3 arguments. First is the string. Second is where we want to start indexing. And then the third is where we want to end it. So again, let's say I have my string, my character vector words, data science is cool, and I want to subset it. Okay, so I'm going to subset words, and I want the first through the 4th character. And it's going to be inclusive, and the first character through the 4th character is, well, the word data, and it's going to return data. And again, I could go longer, and it's going to include more letters or more characters. But that's it. So again, notice that it is inclusive. So if you want to include it, you gotta, well, include it. So it's going to include 1 through 4 inclusive. And again, that counts character by character. Another really important one, and again, this is one that we're going to use quite a bit, is that we want to split our strings up. Because again, from R's perspective, every sentence is just a single character vector, and it doesn't read it in natural language like we would. Again, we see sentences composed of multiple words, each separated with a space. And if we try to do something like natural language processing, or we try to do text analysis, we need to actually break these sentences down for R first, because it's not going to interpret by default individual words. It just sees everything as a string of characters that all have, like hexadecimal representations, and it doesn't know the difference. So the nice part is we can break up our sentences using the string split function, or str_split. So let's say again I have my single character vector words with data science is cool, but I want R to understand that those spaces really are separating individual words, and we should be considering this sentence as actually 4 individual words. So I'm going to use my string split function, right? I first input my string, which is stored as words. And in the second part, my second argument, so again, the comma, my second argument is where to split, and I put that in quotes. So I'm telling it to split every time it sees a white space. Every time it sees a blank space, that's where I want it to split. And if I run my code, I get data, science is cool, and see how they're all separate elements now. They all have their own sets of quotes, so now I have 4 elements instead of 1 element. Remember, the original way I stored words, it was 1 element, right? It was that whole sentence, it was 1 element. Now splitting it by white spaces, now I have 4 elements, which actually represent my 4 words, which is going to be very useful if I want to do some sort of analysis on this text later on. Now, I don't have to use white spaces, because again, R sees no difference. So you can actually split it up any way you want. Again, typically spaces are the most common. We could also use hyphens if I wanted to separate like phone numbers or something. Again, it depends on the context really. But again, it makes no difference. I could split up my string by the character I, lowercase I. And if I run my code now, we'll take a look. My first element now is data, space, capital S, C, and then it finds I. The first I comes in the word science. So it's going to split it up. It's going to cut that string off. It's going to chuck out the I, because that's where we're splitting it. It chucks it out. And then it starts my next element with the ENCE space, and then it gets to the next I. So again, it's going to include the space because it's the character just like anyone else. But it gets to that I, says, all right, chop it off, throw the I out, and then include the last part of my vector. And so it's splitting it up there. So again, you can split it any way you want. It's a really powerful function, and it is really, really useful for splitting all different kinds of data that is stored in string format. Again, including dates and phone numbers. instead of just necessarily having to split with the white space. However, be careful. When we outputted, when we use the string split function, it outputted our result as a list. But again, typically we don't want to store things in lists. We rather have things stored in vectors because vectors have indexes. Now, if I want to store this as a vector itself, we use the double bracket notation at the end of the line of code. So again, if you look at the code down at the bottom, string split, we have words as my first argument. My second argument is splitting up with the white space, and then I include the double bracketed I, and now it has data science is cool, and again, that's one vector. And notice the difference in the output. So I'm going to go back to the last one, see how we had the double bracket notation, which lets us know that it was a list last time. Now it's a single bracket. Everything's in one line, which means it stores as my output is one vector with 4 elements. And I can store my result that way. So again, I'm going to split my words, and I'm going to store that in the vector, well, split words. So now I have a vector called split words that took my single sentence and now has the 4 elements for each one of the words, which is nice because now I can index the split words vector. And so if I index split words, now it's going to actually behave the way we would expect it to. Now when I say index the first part of split words, I am just going to get data because that is the first entry. And now it's much more natural to how we would interpret it. And that's how we can get kind of R to really do what we want it to do with our different types of string manipulations. I can actually index the rest of it too. And I can use the other indexing tool. So again, remember the colon means give it a range. So if I do 2:4, it means give me what's in indexed positions 2 through 4. So 2, 3, 4, which in this case should be science is cool. All right. So again, that's really, really important. That's how we can split up sentences into individual vectors, or I'm sorry, into vectors that have the individual elements as the words. Now, you might also want to combine multiple words into one sentence instead. Maybe you want to take a bunch of words and kind of put them all together. This is called string concatenation. And you would use the str_c function to do this. So you would take a vector that has multiple elements, right, where each element is its own string, and we can combine them all into one single element or one single character vector. So let's take a quick example. So let's say I have now a vector called words where my vector is made up of 4 different strings. So I have learning, R, is, fun. So 4 elements. If I want to put them all together into one sentence, I use that string C function. So string or str_c. And my first input is my string. Then I want to do collapse. So how do I want to collapse it? So it's going to cram all those words together. It's going to put them together. But for us to read it normally so that it looks like a sentence, when I collapse it, I still want those individual elements separated. So I'm going to separate those individual elements with my white space so that, again, it looks like it makes sense to a human being. That's what that collapse argument is doing. And the collapse keyword, again, tells us how we're going to split up the sentence. And again, I could put a hyphen in there, and it would be learning -r-is-fun, or I could put a letter or a $sign or a percent symbol. It doesn't matter. That is called our delimiter. All right, that tells us how we're going to separate the individual parts when we put them all together. And again, typically we're going to use the single space, the single white space, as our collapse argument so that we see the resulting sentence in a way that humans would understand, which means our words are separated, or our words are delimited by that single white space. All right. Next up, changing from lowercase to uppercase. And again, if you recall, the R language is case sensitive. That means that lowercase and uppercase are not considered equivalent. So if I asked R, well, does data equal data? For a human, we'd probably say, well, yeah, that's like the same thing. But notice how one is a capital D and one is a lowercase d, so R is going to return that that's false. They are not the same because the case, right, matters. It is case sensitive. So when we create our identifiers for R, we want to use snake case. And snake case is when we only use lowercase letters and we separate all of our words with an underscore. However, a lot of times when we import data, that's not how it's stored, because somebody was just making a database or someone made an Excel spreadsheet and they just used, well, natural language. And again, we want to make sure that we're being very, very consistent because it's going to prevent us from making mistakes later on. And so that's one of the big things is we need to change everything from lowercase to, or I'm sorry, change everything from a mix of uppercase and lowercase, how we would naturally write things, and change it all to lowercase so that I can do comparisons and filters or just keep everything in that same kind of format. So here's a real example. I found a data set on the top 100 independent restaurants in the nation, and I import that in as my CSV file. I import that into a data frame called restaurants, and when I check the column names, and so we use the function col names, that checks the column names, and I see that my column names are rank, restaurant, sales, average check, city, state, and meal served, except it's not in the right format. Again, every word is capitalized, or at least it starts with a capital letter, and we have spaces between words instead of underscores. This is not my snake case. This is not the right way. So I really do want to fix this. This is, again, when we do that first step of importing our data, we start inspecting it. If our column names aren't given correctly, we really do want to fix that first. So to fix this, there are several functions in the string R family of functions that can make this process much, much easier for us. The first one being string to lower, which is exactly what it sounds like it is. So str_2_lower, it takes a character vector and it's going to convert all the letters to lowercase for us. So again, I want to store my results here. So lowercase column names, that's where I want to store it. So I'm going to store it. I'm going to use my string to lower function, and my string to lower function is being used on the column names of the restaurant. So again, I have nested functions. It's going to work from the inside out, really. So column names of restaurants, it's going to, again, return all those individual elements. It's going to convert them all to lowercase, and then I'm going to store it back in my lowercase column names. And when I check lowercase column names now, boom, everything is now in lowercase. There's no capital letters left. Rank, restaurant, sales, average check, city, state, meal served, everything is lowercase, which is great. I needed that to be done. It's still not perfect though, because I still have spaces between words. So for example, average check and meal served, they're separated with a space. I want to use an underscore. I need to use snake case here. So I'm going to do that in just a second. Just because it does exist and I want to mention it, there is string to upper. It can convert everything to uppercase. You're probably not going to use that all that often because again, snake case requires everything to be lowercase, but if you ever need to bring everything to uppercase, that function does exist. If I want to replace the characters, like I want to replace every space with an underscore, I'm going to use one of the string replace functions. So there's two options. There is string replace, which is going to replace the first instant in the individual element of my character vector. And then there's string replace all, which is going to replace every instance in my particular character vector. And depending on the context, we might want to use one or the other. Again, typically we probably want to replace all of them, but there might be cases where we don't. We just want to get rid of the first instance of it. And I'm going to show you an example of that in just a second, but first let's fix our column names before we do that. So again, to review, we have our lowercase column names, which again, we have rank, restaurant, sales, average check, city, state, meal served. Everything is in lowercase, which is the first step to snake case. And now I want to replace. I want to replace each one of those spaces with an underscore. So the way I'm going to do this, so again, I'm going to use my string replace function. I'm storing this in my new column names vector, because again, I want to store my results. And then again, my first argument in the string replace function is my character vector, which is my lowercase column names. Then my second argument, so comma, my second argument is what I want to replace. And in this case, I want to replace every blank white space with an underscore. And that's my third argument here. All right, so it's my string, what I want to get rid of, and what I want to replace that with. And when I run my code now, my new column names, look at that. It replaced the space between average and check with an underscore. It replaced the space between meals and served with an underscore. Now my column names are in my snake case format, and that standard form that I want my identifiers written in when I do my data analysis or my different projects. All right. The last thing I would do, now that I have my new column names and it looks the right way, I can actually store them back and overwrite the old column names using my new column names by, again, using the column names function, which is really, really nice. So column names of my data frame restaurants, I want to store in the column names, well, my new column names that I just created. All right, so again, we did a couple steps there, so you might want to go back and watch that part again to try to understand. But again, that's really something you should really kind of do and try to put together when you first import any data set and the column names are not in the proper format. All right, now they are, after I do those couple of functions. Now, I want to go back to the string replace and the string replace all and talk about what the difference is, what I mean by instances. So if I have my string replace function and my string is the word mathematics, all right, so the word mathematics, and I want to replace the letter A with the @ symbol, right? I want to be hip and cool, right? Use symbols instead of letters. Well, when I use string replace, it's going to output, well, it replaced the first A in the word mathematics with the @ symbol, right? The part with math, but then the A in the matics part stayed the same. It did not replace all of them, it only replaced the first instant. However, if I use the string replace all, and I take my, again, string mathematics, and I want to replace A with the @ string replace all is going to replace all of them, or in this case, both of them, with the @ symbol. So that's the difference between the string replace functions, whether you want to get rid of all of them or you want to get rid of just one of them. And those are really your only two options here. All right, so I went over that really quickly, and again, I tried to do a very useful example with how we can redo our column names to put them in our standard form. But the string replace and the replace all functions are really, really powerful and really, really useful and have way more applications than I talked about here. And again, I know that's true of most of the things we do in R. There's way more that we can do in this programming language that's been built on for decades now. But you can absolutely set up multiple replacements in vector form. You can choose multiple characters to be replaced at once. You can do a lot of really, really powerful things with this. So please read your textbook. Read this section for some more examples about how you can use these particular functions in more in-depth ways. All right, another really common thing that we want to do when we're looking at strings is we want to check to see whether a string contains a particular word or a substring. So we want to see, okay, we have this text. Does this text contain some particular word? And so we're going to do an example. Let's say we have a review and we're trying to figure out if people like the product. Well, we can look at the review and figure out if it's favorable or not by looking at hopefully positive words like enjoyed or great. And again, that typically is going to indicate that a user liked it. And again, this is that natural language processing type thing. We take a string, right? We take a sentence that some human wrote, and we try to get our computer to understand what was the intention behind it. And again, this is shows up in machine learning a lot, trying to interpret, well, what does the human really want me to do when I'm just a machine type of thing. And again, string detect is the first step. Can we detect individual words that have certain connotations to it? So again, that's str_detect. And so let's take an example. So let's say I have a review. So again, I'm stored in the variable review. I have the entire sentence in quotes. I really enjoyed this product, and I thought it was great for the price. All right. And so I want to see, well, is this a positive review or not? Because again, R does not understand what a human means, right? That's not how humans and computers really can talk that way, right? Computers don't really necessarily understand natural language. So I write a quick function, string detect. So the string I want to pump in is review. And then I want to check to see, does the word great show up? Because great is typically a positive connotation. And the string detect is either going to return true or false. It returns a logical. In this case, it's going to return true because we can read through that review and we see that, oh yeah, the word great is in there. I thought it was great for the price. So the word great was in there. So the string detect is going to say that's true. I detected it, it's true. So again, the string detect function is going to return or output a logical, either true or false. Now, let's say I want to detect in this same review, did they put the word pro in? Is the word pro in this review? Well, I read this as a human as I know the word pro was not in this review, except string detect is going to say yes. Yeah, it is. Pro is in here. Absolutely. And the reason that is that pro does appear, but it appears as part of the word product. All right. And that's because, again, and I mentioned this before, and I'll mention it again, R does not understand language the same way that we understand language. All right. What's going on here is a little bit different from the way humans interpret language. So it's really important to know what's going on here. So from our perspective, we would look for the word. But from R's perspective, it's much more subtle. It's checking to see if that substring is contained at all in there. And again, remember, R doesn't care whether it's a space or a letter or a symbol. That's all the same to it. It doesn't understand words unless we use functions to specifically split up the words, as we've seen. And so we can really run into trouble here if we are not careful when we use our string detect, because we can detect things that are in our sentence that might not have the same sentiment that we expect it to have. And again, when you look at that example with the word pro appearing in the word product, yeah, it's going to think that's true, even though a human wouldn't make that particular mistake. So again, really a problem for when we try to detect small words that are very common and show up in bigger words. All right. Those are our main functions that we're going to use from the string R package. And again, hopefully we understand a little bit how R interprets strings really as our character vectors. So let's see if we can answer these following questions. What code would I write if I wanted to replace every instant of the word dumb with the phrase was not up to expectations in a particular vector? So again, very, very general. I didn't give you anything else more specific than that. What function would we use and what would go where? How would I set that up so that I get rid of the word dumb with something that sounds, well, a little bit classier, right? Number two, we did that whole example where we took our column names that were not written well and we converted them into the snake case, which is written the way we want it to be done. But I did that it took me a while, right? I had to go through a bunch of different steps and I had to store things in intermediate variables. Can you expedite that process? Can you actually try to take what we did and pare it down to something much smaller? Almost like, can you write your own function to convert column names into snake case regardless of whatever we start with? So again, go back to that part of the example in the video about midway through and be like, how can I try to make this more concise? How can I do this in a way that's a little bit faster and easier for people? Lastly, that string detect function. What would the result of the following code be? If I ring string detect and my string is I was greatly disappointed and I am checking for the string great, what would it return? First of all, what does the string detect return? Does it return integers, doubles, logicals, characters? What does string detect return? And then what would the actual result be of what it returned? And would it be what a human would probably say asking that same question? If some human read the phrase, I was greatly disappointed, would they think that the person meant that it was great? All right. That wraps it up for this video. Hopefully we learned some things. I know there's a lot to go on with the string R family of functions, so make sure you review this a couple times, take some good notes, and as always, take care of yourselves.